Hello viewers, welcome to my channel KK Concepts of Electrical Engineering.
Gradient of a scalar field. Gradient is not a vector, it is an differential operator. Gradient is an operator denoted by the del, so this is also known as gradient or del operator. Del is a differential operator which is given by dou by dou x of ux plus dou by dou y of uy plus dou by dou z of uz. Let V is a scalar field. Gradient of V or gradient of V or del of V is equal to dou by dou x of V ux plus dou by dou y of V uy plus dou by dou z of V dou z. Now the gradient of V is a vector. Gradient of V is a vector. The gradient of any scalar function is the maximum space rate of change of that function. Divergence of a vector field. Divergence of a vector field. Now let again V is a vector field represented by V equal to Vx ux plus Vy uy plus Vz uz. Divergence of V equals to dou by dou x of Vx plus dou by dou y of dou x plus dou by Vz of dou z. Divergence V is equals to dou Vx by dou x plus dou Vy by dou y plus dou Vz by dou z. This is nothing but del dot V. Divergence of a vector is a scalar. This del dot V equals to 0, then a V is said to be or solenoidal vector. Divergence free vector. Until now we have seen two operators, that is gradient of a scalar vector or else grade or del operator, gradient to a scalar field V, then this is the formula Let it be equation number 1. We have seen the divergence of a vector field, then divergence of V is our equation number 2, that is del dot V. Now we will see one more operator, that is Laplacian Laplacian of a scalar field. Let V is a scalar field, then gradient of V or del V given by equation number 1. Divergence to gradient V, which is nothing but del dot del V dou by dou x of dou V by dou x plus dou by dou y of dou V by dou y plus dou by dou z of dou V by dou z, which is nothing but dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. Let this be equation number 3. So divergence of del V is equals to del dot del V, that equals to del square of V. Laplacian operator del square, which is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Laplacian of V equals to 0 is the Laplacian equation. V is called harmonic function. Cu or curl of a vector field. Now let V equals to Vx Ux plus Vy Uy plus Vz Uz. Del equals to dou by dou x Ux plus dou by dou y Uy plus dou by dou z Uz. Curl of V is equals to del cross V, which equals to Ux, Uy and Uz, then dou by dou x, dou by dou y, dou by dou z, then Vx, Vy, Vz. Del cross V equals to dou Vz by dou y minus dou Vy by dou z of Ux plus second term, that is Uy, dou Vx by dou z, this term and this term, minus this term into this term, dou Vz by dou x, next plus last term, that is Uz. Now these two terms and these two terms, dou Vy by dou x minus dou Vx by dou y. So curl of V is again having Ux, Uy, Uz terms, is a vector. Curl of V is a vector, and curl of V is equal to 0, then V is curl free vector or irrotation rotation vector. We have seen gradient of scalar del V, which is a vector, divergence of a vector, that is del dot V is a scalar. Laplacian of scalar field del square of V, curl of a vector field, that is del cross V, which is also a vector. In our operating cases, del is defined as dou by dou x of ux plus dou by dou y of uy plus dou by dou z of uz.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.